Lesson 6.2, Trigonometry. Dealing with trigonometric equations, Part 1, and I think that this will be somewhat refreshing compared to the last couple lessons that we've done. So let's do example 1, 2, sine of theta, and the book's got it wrong. It should be plus 1 equals 0. And what I'm going to do is when I get a trig function like that, I'm just going to say off to the side just to remind me that it equals x. So then I can rewrite this like this. So therefore, if sine of theta equals x, then I can replace that. Sine of theta then equals negative 1/2. Alright, so let's move all this up here, because all we care about is the sine of theta equals negative 1/2. Now what they say here is that they want to know where that angle is between 0 and 360. So they give me an interval there to graph this. So if I graph this at theta equals negative 1/2, I know that if I did use my calculator and I put this here, I would get a 30-degree angle. So I know that a 30-degree angle, but I get a negative 1/2. All students take calculus. So I know that my sign is going to be negative there and there. So my quadrants are going to be in quadrants 3 and 4. So that being the case, I'm just going to draw a 30-degree angle there and a 30-degree angle there. So what I'm interested in finding out then is where are those? What angle is that? And what angle is that? Well, this first one here is going to be 180 plus 30, so it's going to be 210. So that's a possible angle. And this angle right here is going to be 330 because it's 30 short of being 360. And so what I want is all the answers. It says solve over the interval 0, 360. And those are the two possible answers that I can get. So let's look at example 2. I've got sine of x tan x equals sine of x, and it gives me again the interval that they want these angles in, because it could be more than just one angle. In fact, in this case, we're talking 4 different angles. So let's see what we've got here. We're looking for x, so we're looking for the angle where when we take the sine of it times the tangent of it, we get the sine of it, which seems kind of weird. Okay, so we're going to do algebra. Let's pretend that we can just set this equal to 0. I guess we're not pretending, we're actually doing it. Minus the sine of x equals 0. And the reason I did that is so that I can put all my signs together and factor a sine out. Okay, so then my sine of x has to equal 0, or my tangent of x minus 1 has to equal 0, so that when I multiply this times whatever's here, I get 0. So either this has to be 0 or this does. This one isn't solved yet. I haven't solved for tangent yet. So I'm going to move my 1 to the other side, just like I do, in algebra. So the sine of x equals 0, or the tangent of x equals 1. So I'm looking for an angle, right there, that when I take the sine of it, I get 0. Alright, so let's see what we've got here. Sine of 0, that's opposite over hypotenuse. At what place is the opposite over hypotenuse going to be 0? Well, I know that my hypotenuse can never be 0, but my opposite can be 0. So 0 over anything is 0. So when is my opposite 0? My opposite is 0 when I've got an angle that is 180 degrees, because as this goes down to the line, then that opposite will become 0. So at 180 degrees, I'm at 0. And then I'm also 0 at 0. My opposite, this line right here, is 0. So those are two options there. Now let's look at the tangent. When is the tangent 1? Well, the tangent is opposite over adjacent. So whenever the opposite and adjacent are the same number, that's a 45-degree angle, right? And I've got, except that's negative 1, 1. So that one won't work because I'm interested in when it will be just 1. So that happens at a 45, whoops, wrong button. It happens at a 45-degree angle. And it also happens, all students take. Third quadrant tangent is also positive. So that's negative 1, and opposite over adjacent. Negative 1 over negative 1 is positive 1. So that works. So it works at a 45-degree angle here, and it also works at 45 plus 180, 225. So there's two angles, and there's two angles. So all four of those are going to make that a true statement. And that's it for 6.2a.